Hello friends, in today's video we are going to talk about the design of the membrane system, okay, or you can call it the reverse osmosis system, okay, using the IMS design software. Okay, so in today's video we are going to compare the IMS design app as well as the IMS design which is called the cloud. Okay, I showed you in my earlier videos how we use the membrane software, IMS design software, when we want to work with the cloud. So now if I'm trying to log in, for creating or opening the cloud, you need to register, okay, with your email ID. Okay, now I will click on the new projection, and there are three options. First one is Hydra Cap Max RO or Hydra Cap Max RO. So let us click on the third option, and this third options allows you to change. Okay, if you see in my app, for example, I'm clicking on the new project. So here it does not allow you to change the CO, CO3 and E conductivity. Okay, so it is totally dependent on the pH and the ions that you enter. And for example, if you see the app, in the app it allows you to even add turbidity, which is not similar to here. There is no option for turbidity here. Even if you try to change, do some settings here, so here also, okay, for example here also flow diagram setup also, okay, there is no such option for turbidity. So there are some differences when you work with the cloud or when you work with the app. So now let us go to the app, and this is our case study which we will solve. So in this case study we are basically going to design the RO system for reuse of wastewater from the common effluent treatment plant. So now let us go to the main part, okay, to the design part. So here for the RO treatment plant, the height of the storage tank is 15 feet and motor power is 0.5 horsepower, and the maximum flow is 6.75 gallons per minute, and the maximum pressure is 175 psi. Temperature is 100 degree Fahrenheit and service life is 1000 gallons GAL. Okay, and recovery was achieved up to 75%. Is effective for removal of the TDS. Now for the design data, it is 1400 meters cube per day, and flow of the wastewater was 58.33. Dissolved solids is 10,000 milligrams per liter. pH is 6.5 to 6.8, and COD BOD turbidity. Okay, so we will enter the turbidity here, which is 3 NTU, and also we will give this a name. So let us give this a name as WTP RO, and client name, for example, I will put IAU, and calculated by you can change here. You can say it is not changing, so leave it. And pH would be 6.5. Depending on these values, the values are changing. Now these are the formula for salt rejection. Salt rejection means 1 minus product concentration upon feed concentration into 100%, and also it means product TDS upon feed TDS into 100%, or it also means 1 minus percentage of salt passage, and it depends on the feed water temperature, composition, operating pressure, and the type of membrane or element and material, and also the pre-treatment. And recovery is QP upon QF into 100, where QP is the product flow and QF is the feed flow. Now go to the methodology. So in the methodology they have used a design. So we will just go to the design. So here if you see, this is my design window, project window. I mean now the temperature here is, pH is 6.5. and also there is a term called SDI which is not showing up here. So let us see if we can add. So here it does not allow. Now we will again open this one. because we went to the dashboard. So here, let us see, make this again. Let us leave this. And now the feed is wastewater. You can also put full screen. Now and the temperature is 27. Then we have a couple of values, which is if you try to increase the font or zoom in, this is 1000 ppm calcium. Then magnesium is 500. Then we have sodium is 128. Potassium is 15. And ammonia is 45. We were on the analysis window, right? So here I have entered all the values of the anions and cations, okay? And also you can see the difference between the cloud form of the app or the IMS design software, and as well as the app which we work offline. So here it allows you to do a lot of settings, okay? And also there to do the some settings which is a bit different from the app. So here you can, if you want to do prompt for auto balance, design screen, so here you can use all. And if you don't want show auto float, you can click not to show, and these more options. So if I want to save, I will save. And then there are more things like I have some documents here, and also the water chemistry. Okay. Now we'll go to the design window. Design window, what we need to do is, and also on the analysis window, the water type is, I think this is well water. So there is no such options here. So we will leave it to industrial waste, and then we'll go to the design window. In the design window, we have to enter the feed pH. So the feed pH here is 5, and the temperature here is, already we have changed that. And then the permeate recovery is 65, and this is already 858 on the main window, which is the analysis window, the total TDS. And the membrane age here is 0, and the permeate flow is 16 meters cube per hour. The average flux rate will be calculated based on the permeate flow, and the feed flow is also the output variable. Now the flux decline here is 7, and the okay, this is okay. Now we will choose the membrane. So membrane, they have choose the LFC3. So here already we have chosen the element and vessels, and this is 1 pass and 2 stages. Okay, now let us run. Now this is the warning, we need the anti-scalent, and also there the membrane that we choose are of different types. Some are low fouling, some are high fouling membranes, and some are used for softening, and some of them are used in case of higher salt rejection. So you can see here this is red here, which is the highest flux, and Also, if you see here, the TDS of the permeate is 627, and if you see in the case study, it is around 839. Okay, and this is my float diagram. If you want to see the float diagram here, so you can see the float diagram. So this is our float diagram. Okay, now if you want to see the results in the print format, so here this is my print format, and this is my permeate, and this is the concentrate, and this is my raw water. Okay, now in the case study, this LFC3 means it is a low fouling technology, and it can treat high TDS wastewater, and the permeate flow is 11,000 GPD, which is equal to 41.6, and it has high solid rejection rate, which is 99.7. And the design configuration for the low fouling spiral wound is the composite is made up of polyamide and is naturally charged, and the area is 400 feet cube. Okay, and in terms of meter square, 37.1, and the feet spacer is 34 MIL, which is equal to 0.864 millimeter, and it can be applied. Maximum applied pressure is 4.16 megapascals, and the maximum chlorine concentration is less than 0.1, and the temperature is 45, and the pH range is 2 to 12 or 1 to 12, and the turbidity could be 1, and these are the other limits. So already we saw the design part and the membrane that we chose, and this is my PDF window that I showed you there. So there is a little, variation from the result that the reviewer or researcher got, and then we got. Okay, and this is perhaps they have run in more arrays or more stages. Okay, and the conclusion, or you can say that the efficiency of the filtration system can remove turbidity in the ratio 3 to 5, or you saw we added this turbidity in the analysis window. If the units are expanded to the quality to be treated, experiments to be carried out, and these are RO reject has to be handled carefully, and the proper maintenance of the plant is required, and the replacement of membrane as per the requirement has to be done to time carefully for successful operation of the plant. So this was all about the case study related to the treatment of the effluent from the treatment plant.